we go. We are recording. This is our lab for Design 350. What we're going to do, and oh, my topics are all wrong. What we're actually going to do is review how to do the AutoCAD for today, and then I'm going to take people out and we're going to do the lab for reading the azimuth angle. And on Friday, I'll show you, if you haven't done the I'll also try to make a little video. I'll try to make a little video of the simulation so that you can see what I'm looking for there on how to read the stuff on that. So here we go. I'm going to pull up AutoCAD. What you see is the first one that I drew last week. It's property number 1. And there's a few things. One, I can take that image that's on there and I can move it around. But what I want to do is get the dimensions of all of these as distance and azimuth from my 0, 0 point. So let's see what that looks like. When I go back to my model, you can see here, and let me get this back to a view that works a little bit better. I'm going to go to light, and I like my white background. It just looks easier on my eyes. So this is my station, my theodolite, and I know that this line is a certain distance at a certain angle, and so I can describe these points that way. So the other thing that I need to do, let me bring this one down, is open up the survey. Where is my, did I not put the, here it is. Here's my service survey record that I'm going to use this week. So it looks just a little bit different. So I want to, on this sheet here, which has distance and azimuth angle, I want to take these readings. Okay, so I'm going to put those side by side so you can see them both at the same time. I'm going to squeeze them down just a little bit. Come on, I know it can go over. There we go. So you can see I've got a property, and now I want to record the distance and the azimuth angle. So the first thing I have to do is I have to look at my units to make sure that AutoCAD is talking to me properly. So I'll type units. And I'm in decimal feet, that's good, but I see AutoCAD is talking to me in surveyor's units. North 0 degrees, and I want my azimuth angle in decimal because that's what's on our machines, right? That's what's on our machines. So I'm going to change this to degrees, minutes, and seconds, and degrees, minutes, and seconds. And I happen to know that our theodolite does angles measured clockwise. So I'm going to measure my angles clockwise. That's the opposite of what they normally do in AutoCAD. I'm going to go clockwise, which means, just as an example, if this is my 0 angle, to measure clockwise, I'm going to measure start, center, end. Start, center, See, that's going counterclockwise. So let me, I thought I had, let's see. Let me go, I don't remember which way to go here. Start, center, end. Start, center. There it goes. That's going to be my angle. Okay? Clockwise angle is what I'm going to read on here. Now, you don't need to have that on there, but sometimes it's good to remember. So, again, I don't care which point I go to first. I'll take this one as my first one. Right-click Properties, and my Properties bar is right up here. And I can see my length is 84.6463. So my distance is 84.6463. And I'm going to write it down, the whole thing. I can fix it up later. And it's, see over here, it's 141D, 141 degrees, 14 minutes, 4 seconds. And I can write it like that so that it's really clear. If I already know what I'm doing, I can say 141 space 14 space 4, and I could write it like that, but I'd want to make a note somewhere that means 141D 14. So it depends on how you want to actually write it down. Okay, so let's take a look at my next one. My next one would be this line. And that's a length of 211.5585. And it's at 288.1041. 288.1041. And this is the same data as what you put in by the XY. I'm just doing it in a different way. Okay, that's why you're using the ones that you already drew. So my next one is 299.4745. And the angle 317, 50, 32. And then my last one is 228.2389 and 346, 3421. And that describes the same property as you did last time, right? Because I'm using all the same stuff. And so what would you do in your submittal? You would take a snip of this as your drawing, maybe do a little bit better, and you would take a snip of this as your data. So that's what goes into your submittal. Now, I don't care whether these were, if there was a mistake or anything like that on your first set, you did 6 of them, I don't care. I want you to show that they're the same, right? So don't try to go back and fix anything or redo anything. Just use the same drawing that you already did. And just put this data in there. At some point, I'm going to ask you to collaborate and trade, make somebody make your drawing and overlay it over yours and make sure they're the same. That's what careful surveyors do. Okay? So we're just kind of doing it a little bit at a time, 1 week at a time, getting used to AutoCAD and drawing. But you can see we can draw this way. Now, what's interesting is this is how you actually record the data when you're out in the field. This is more commonly done unless you got some really good geopositioning stuff that takes your XY or a drone. Drones all go by XY. That's why we started with the XY. But surveyors that use these machines usually use this format, distance and an angle. Okay? So you're just getting used to it, moving along slowly with it. That's cool, but it'll give you some practice. Any questions about how to do the AutoCAD part of it?
I have a question.
Yeah, JR.
What is that circle thing again? I
That's
didn't.
just showing you where the angle actually is measured. So I'm measuring a clockwise angle. This is my 0 line, and so the angle for this one right here is measured from here all the way around to here, right?
Okay, so that's the. Do we
That's
have to do that for all of the lines or
Well,
just?
no, you don't actually have to put that in. If you want
Oh,
to, you can do that. I'm just showing you that um, our machines measure angles in the clockwise direction.
oh, okay.
So when you do your units, you want to make sure that your angles are measured in a clockwise direction. And we're so used to seeing the angle being like from here to here, 45 degrees, but it's in this case it's way around the long way. Okay? So that was the only reason that was on there, was just to show where the angle is actually being measured. And that's why these numbers are so big, right? You're getting all these 200s and 300s and 350s, and that's because the measure is all the way around in the clockwise direction. Cool? Did that make sense?
Yes, thank you.
Cool.
I have a
Okay.
question for you, Professor.
Yes.
So I got a question about the arc itself. Did you use the center start angle arc, or did you
No, I had
use
to go the other way.
start center angle arc?
Yeah, so I did, well, yeah, I did start, center, end, but since I know that it always goes the other way, I started with my end first, right, to get it. So I did it back. I did start, center, end, but I did my end first. It's very hard to figure out. Here's the easy way. I tell you what.
Oh, okay. I think I
Here's
get
the
it.
easy way. Make a circle and trim it.
Okay.
Trim what you don't want. Like, that's the other way to do it.
Yeah.
Make a circle and trim what you don't want. Probably quicker and easier. Cool. Okay, any other questions? Those are all good questions. Okay, well that's just the talking part. We're going to go ahead and get set up outside now. I'll take some videos of it. I am preparing some stuff. Oh, let me just show you on the Jamboard, which I put up for you. I want you guys to, where did I put the Jamboard? I thought I put it on here somewhere. I think I just did it in a video. So let me open up my Jamboard and I'm just going to go over it. I did this in a video for you, but I'm going to go over it again and then I'll give you a link to this Jamboard. So there's 4 pages to this, by the way, okay, that you can go through. And so what you see here, and let me do a share and I'll pop it in there. And I'll put it in the reading. Uh, Eric, yes. How to plot topo lines? Do we have one where you have to do that yet, or do you just need to know how to do it?
That was the fifth drawing. I on the last take
Oh,
I could not figure
yeah,
that
I
out.
don't need the topo lines. I just want the corner points.
There was on that one there was like three planes versus two, so I don't know if I was just going in the wrong order.
All I wanted was X and Y coordinates of the corner points. It didn't want all the topo lines.
Okay.
Yeah, just X and Y of the corner points. So I'll bring that one up too. So here we go. This goes up in your reading. So here's how to get to this one if you want to be able to take a look at it. So the question is on these plates, on this one, I'm so sorry, you don't need the Z elevations. All I'm looking for are the points around it that go. And I'm not even positive. I took this from a student, and so I'm not even sure that they're right. Okay, but whatever plots out is what you want, and do not worry about the Z elevations. And I don't need the topos. I just want the property lines. Cool. So now I understand your question, Eric. Sorry about that.
Yeah, I was lost. I was like, I can't find it.
What do we need that for? No, we'll be doing those later on as we go. So just plot the X and the Y. And I'm not even positive that they make this shape because I just grabbed this from a student submittal from last semester. Same with the, like the other ones I all kind of got. So let's take a look. We're going to work on azimuth angle and distance. So we know how to set up the theodolite. We know how to place a rod against a wall. And I'm going to pretend there's a zero angle somewhere over here. And I don't know where it is. It depends on where you set up your machine and how you set it on the thing. We don't really care where zero is, because you're going to find out later on we're always going to reference to some known points. So zero is somewhere, and this rod is some angle reading in your theodolite. And so the trick is, how do you get that reading? Okay? Because we'll learn eventually how to get the elevation reading. Right now, we're just going to measure the distance to the rod and this azimuth angle. Okay, so now we have to remember that there's 360 degrees in a circle. So this looks like about 45 degrees, right? 90, 180, 270, all the way around 360. And that's cool, but that's pretty clunky chunky for a survey. So they want to get better than that. So each degree is cut into what they call a minute. So each degree is cut into 60 parts, and that's because the watchmakers, the clock makers, were the craftspeople that made the first sextants and things like that. So they already knew how to do that. How did they know how to do that? Well, even all the way back to Mesopotamia, but the Middle Eastern and North Africans taught the Greeks how to cut things into 60s. Okay? And that's just by doing stuff on a circle. It was very easy to do and get exact. And so that's why we're stuck with 60s, because you could do it exactly using geometry in a very simple way. That's sort of the history behind it. So we have degrees. They're cut into minutes, and that's pretty good, really, for what we do. That's good enough. But if you do anything long, the farther away you go, if you're off by a little bit, you get farther and farther and farther off. And so real surveyors go down to seconds, and then they do tenths of an arc with tenths of a second. And boy, that's really good. If we can get to minutes, degrees, and seconds with some sort of reasonableness, we're okay. So how do we read it? When you look through the little scope, you're going to see something up here that we're going to ignore right now. That's why I left it blank. Okay, and you're going to see a bottom scale and a middle scale. The bottom scale is your degrees, and the degrees, if there's a double line in between this stuff, it's the one that's straddling a double line somewhere as best you can see. So this one, you see the 246 is off to the side. You can't see the other one. It's obviously 245 degrees because it's in here. Okay? And so 245 degrees and 50 minutes. And then we have to figure out better minutes. 3, 50 plus 3, and 20 seconds minus a little bit, we'll call it 18 seconds. Okay, so when you look in that thing, you're going to look for the H. You're going to see two numbers, usually, and you're going to pick the one that's really lined up best across two of these. And you're going to say, okay, it's 245 and 50-ish minutes. And you're going to go up to the fine scale, and it's like, oh, it's really 53 because it's nearest, it lines up in the threes. And then you're going to look for the seconds, and you're just going to sort of estimate it. Okay? And that shows up once you get the reticle lined up on the rod. So our first step is line up the reticle, the little target, in the eyepiece on the rod and get it focused. Then you're going to look in here. And here's just another one that would show, you know, that's what it is. 245, 53 minutes, 18 seconds. And we're just going to practice that. I'm going to set up some rods. You guys go set up your equipment. I'll show you how to twiddle the buttons, and away you go. Cool? And we'll do the same thing on Friday. All right? And you'll do the same thing from here on out. You will always be practicing this as we go. Cool? Okay, there we go. Any other questions before we turn this off? All right, I'm going to turn off the recording.